Hi and hello to everyone. In this video, we are going to see the properties of Laplace transform. Welcome to the lecture. First property is our linearity property. What is linearity property? If a time domain signal is x of x1 of t and x2 of t, the corresponding Laplace transform are x1 of s, capital X1 of s and capital X2 of s. Remember that I differentiate the time domain signal and Laplace domain signal. If I use small x, that is in time domain, inside the bracket it will be t. In Laplace domain or the frequency domain or the s domain, all are the same. Okay, Laplace domain or I can say it is in s domain or frequency domain. All are these all are same. Okay. So if x1 of t Laplace transform corresponds to capital X1 of s, x2 of t corresponds to Laplace transform corresponds to capital X2 of s. Okay, suppose if a into x1 of t plus b into x2 of t, if I want to take the Laplace, I indicate by the symbol notation L, right? It is equal to a into what is the Laplace transform of x1 of t? It is x1 of s. What is the Laplace transform of x2 of t? It is x2 of s. This property is called linearity property, right? Now using linearity property, look at an example. Find the Laplace transform of x of t, which is given as 2 into u of t plus 3 into delta of t. Okay, here I am saying this is, let me say this is x1, this is x2. What is the Laplace transform of u of t? It is 1 by s. So x1 of s is equal to 1 by s. So 2 is a constant. So 2 by s. What is the Laplace transform of impulse signal delta of t? Laplace transform of delta of t is 1. So 3 into 1. So x2 of s is 3. So I can add those two. x1 of s plus x2 of s. Okay. Right. Now look at the ROC. For 2 by s, the ROC is real part of s should be greater than 0. It since u of t is a causal signal, okay, it is greater than 0. Okay, for impulse signal, the Laplace is the ROC is entire S plane. Now, when I'm going to add these two, it should be common to both region, right? So, what is common? Greater than 0, entire S plane. So, common region is for the given question x of t, the Laplace transform is 2 by s plus 1. The ROC is, which is common to these two ROC, that is, real part of s is greater than 0. Okay, so I have solved this problem using linearity property. That is very simple. Take individually Laplace transform for this, take individual Laplace transform for this, then you add those two Laplace transform. That property is called linearity property. Next, we'll look at the second property, that is your transform of derivatives. It is also called differentiation in time domain. Differentiation. Differentiation in time domain. Okay, here the let the Laplace transform of x of t is x of s. So if I differentiate the x of t with respect to t, it will be is equal to s into x of s minus initial condition. Okay, I can extend this to 2 times differentiation of the given signal x of t is equal to s square into x of s. 2 times differentiation means 1 time differentiation I multiply with s. 2 time differentiation I multiply with s square, and the corresponding Laplace transform of x of t is x of s minus s into initial condition minus differentiation of the initial condition. Okay, so suppose if people are saying that initial condition is 0, initial condition is 0 means what happens? This entire term becomes 0. So the dx of t by dt equal to s into x of s, d square by dt square x of 2 time differentiation of x of t is equal to s square into x of s. When the initial condition is given, you cannot ignore these terms. If initial condition is 0, you can ignore this term. If this is 0, I can remove this. If x of s, if the initial condition is 0, I can remove this term. Okay, now we will see that we will know what is the Laplace transform of u of t unit step signal, that is 1 by s. Okay, now I am going to differentiate the unit step signal. right? If we differentiate the unit step signal, what is the property says? One time differentiation is s into x of s. S into, what is x of s? This is my x of s. So 1 by s. So 1. Okay. So we know that this is the unit step signal. This is my u of t. Okay. What is d differentiate? If I differentiate this, what I will get? I will be getting the impulse signal. This is nothing but delta of t. Okay, so we already know what is the Laplace transform of delta of t is 1. By using differentiation property also, I have proved that we are getting as 1. Okay, so very simple, you can remember, if a signal is given, x of t is given, if you know the Laplace transform, if the differentiation of that signal is asked, just multiply with s and put multiply with s into x of s. Minus, if the initial condition is given, you subtract the initial condition. Similarly, do that for 2 times differentiation if it is asked. This is called differentiation in time domain or transform of derivatives property. Next is transform of integral. Okay, in this, if Laplace transform of x of t is equal to x of s, then if I integrate x of t, integrate x of t with respect to t, just if I one integration means you have to multiply with 1 by s. Okay, differentiation in the last slide we have seen differentiation means multiply with s. 2 time differentiation means multiply with s square. Similarly, integration means multiply with 1 by s. 2 times integration means 1 by s square. Multiply with 1 by s square. This is called integration in time domain, or also can be said as transform of integral property. Okay. Next is an important property called scaling property. What is scaling property? If x of t, Laplace transform of x of t is equal to x of s, then what is the Laplace transform of x of at is equal to, this is called time scaling. Okay, here the time is scaled by a. Just you have to take this a and you have to divide by 1 by magnitude of a. X of, in place of s, you substitute s by a. In place of s, you substitute s by a. Okay, now we will find out, you will use this property and we solve a problem. Okay, that's what given here. If we know e power minus bt u of t, e power minus bt u of t is 1 by s plus b, 1 by s plus b. But the question is, find Laplace transform of e power minus 2 bt u of 2t. Okay, we observe that what is happening here, instead of t, here it is 2t, instead of t, here it is 2t. So what property I can apply? Time scaling property. So here it is scaled by a, so 1 by magnitude of 2, magnitude of 2 into 1 by, in place of s, in place of s I am putting s by 2. Okay, in place of s I have put here s by a, here a is 2, so 1 by magnitude of 2 into 1 by, in place of s I am putting s by 2. Okay, plus b. On solving this, we will get 1 plus s plus 2b, 1 plus s plus 2b. Okay, this property is called time scaling property. Next property is your time shifting property. In time shifting property, if the Laplace transform of x of t is equal to x of s, what happens? What is this? This is time shifting. The signal x of t is shifted by t naught units. Okay, so that's equal to e power minus st naught. Remember how much time I'm shifting? Just you have to put it in the exponential in the frequency domain or the Laplace domain. E power minus s t naught into x of s. Okay, now look at this example. You can understand clearly. We know the Laplace transform of u of t is 1 by s. So what is the Laplace transform of u of t minus 2? I can apply what property? Time shifting property. Okay, how much time it is shifted? 2 units it is shifted. So e power minus 2s into 1 by s. What is the Laplace transform of u of t is 1 by s. So multiply with 1 by s. So I am putting x of s here. Like that I am putting 1 by s here. Okay, next is if it is t plus 3. T plus 3 means e power 3s into 1 by s. U of t plus 3 means e power 3s into 1 by s. Look at the other examples. We know the impulse signal Laplace transform is 1. T minus 1 means e power minus s into 1. T minus 4 means e power minus 4s into 1. Delta of t plus 3 is e power 3s into 1. Okay, so if you know the original signal, then just you put t minus a means e power minus as into original Laplace transform. Laplace transform of the original signal. Okay, that property is called time shifting property. Okay, using time shifting property, we will look at a problem now. Okay, find the Laplace transform of x of t e power minus 5t u of t minus 5 and its ROC. Okay, so first thing we have to write the expression in the form of time shifting property. Okay, so just I multiply inside, right? So if you observe this, it is, sorry, here it should be, okay, here it should be t minus 4. Okay, t minus 4, right? Only thing I have done is I have multiplied these two inside, e power minus 5t, e power minus 5t, I have multiplied individually, right? Okay, so observe this closely, very important. Here it is t minus 4, but here we have only t. Okay, to apply the property, this term should be also equal to t minus 4. So what I do is, I am taking minus 5 outside. So in place of t, I have put, in place of t, I have to put, I am subtracting minus 4, I am adding plus 4. I am subtracting minus 4, I am adding plus 4. Okay, so meaning is the same, it won't change, right? Now what I can do is, I am multiplying with minus 5 with 4, so it becomes e power minus 20. The remaining terms e power minus 5 into t minus 4, I am writing like this, right? So this is, okay, this should be t minus 4. Now I am rewriting it again, bringing this term this here. So e power minus 5 t minus 4 into u of t minus 4. This is e power minus 20 is a constant. Okay, so if you observe this closely, what property is this? Time shifting property, because here it is t minus 4, here it is t minus 4. So I can apply time shifting property. Now I can take Laplace transform. What is the Laplace transform of e power minus 5t u of t? It is 1 by s plus 5. E power minus 20 is constant. Okay. Right. How much it is shifted? T minus 4 it is shifted. So I am multiplying with e power minus 4s. Since this is a, so e power minus as. T naught is 4. So e power minus t naught s. That is a property, no, the last slide we have seen, right? So t naught is 4 here. So e power minus 4s into original signal Laplace transform. That is 1 by s plus 5. Okay, other things are just mathematical manipulation. Just I am multiplying inside. Okay. Then I am taking minus 4 outside, so it becomes a minus 4 into s plus 5. Then I am, that's all. Okay. This is the way to solve. By using what property? I have applied time shifting property. Okay, if it is a problem, remember this step is very important. You cannot apply, if it is u of t minus 4 alone, you can apply time shifting property, but it is coming along with an exponential term which is a function of t. So this t should be also t minus 4. For that only we are doing these two steps. But here we can apply the time shifting property. Based on the time shifting property, I have written this is convert time domain to S domain or Laplace domain or frequency domain. I have converted. Okay, right? You can mark it here. So Laplace transform of this is this. Laplace transform of this is this. This entire term. This entire term. Okay. Next property is the frequency shift property. What is frequency shift property? If the Laplace transform of x of t is x of s, then e power minus at x of t is equal to, in place of s I can replace with s plus a. If there is an exponential term in the time domain, it is shifting in the frequency domain. If it is e power minus at, here it becomes s plus a. Okay, here if it is e power at, here it becomes s minus a. Using this property, we are going to find out the Laplace transform of e power minus 3t cos 2t u of t. Okay. So we know what is cos 2t. Okay, we have seen in the previous lecture, previous video. Okay, in that basics of Laplace transform. Okay, we have derived that cos omega naught t is equal to Laplace transform is s into s square plus omega naught square, right? Here in place of omega, what is there? 2 is there. So s into s square plus 2 square. Okay, here what is there? Exponential term is there in the time domain side. So it should be shift in the frequency domain. That is called frequency shift property. Exponential in time domain is equal to shift in the frequency domain. Here it is minus a means s plus a shift is happening. Okay, so here it is e power minus, if here it is e power minus 3t, e power minus 3t. So it becomes s plus 3 into s plus 3 whole square plus 2 square. Okay, so what I have done here, in place of s I have replaced with s plus 3. Since it is minus 3, I have replaced with s plus 3. Suppose if it is e power 3t, suppose if it is e power 3t, it becomes s minus 3. S minus 3. Okay, right? So this is the answer for e power Laplace transform of e power minus 3t cos 2t into u of t. Just in place of s, since exponential there in the time domain, in frequency domain I am shifting by s plus 3. Now we look at other property, differentiation in s domain. Okay, that's a differentiation in s domain. So if it is x of t equal to x of s, minus t into x of t gives d of differentiation of x of s with respect to s. Okay, now the question is find the Laplace transform of minus t e power minus 2t u of t. This is the question. Okay, so we know e power minus 2t minus 2t u of t is 1 by s plus 2. What is that? You are asking minus t into this signal. Okay, minus t into signal x of t means we have found out x of t, that is your 1 by s plus 2. So minus t means d by ds into 1 by s plus 2, the differentiation of this signal. Okay, so simple. See, you find the Laplace transform of this. If they are asking for minus t into that signal, so minus t means immediately what you can do, d by ds into that original signal. Original signal is this signal. Corresponding Laplace transform is 1 by s plus 2. So 1 by s plus 2. So if you differentiate this, you'll get this answer. Okay, with respect to s, you'll get this answer. So this is the Laplace transform of minus 2 e power minus 2t u of t using what property? Differentiation in s domain property. Next is very important, time convolution. We know in convolution in time domain is very difficult. We have to do integration. Okay, here in convolution in Laplace domain is just a multiplication. Right, so this is the convolution symbol, star symbol. If x1 of t and x2 of t are convolved, that is your convolution in time domain is equal to just multiply the corresponding Laplace transform. For x1 of t, Laplace transform is x1 of s. For x2 of t, the corresponding Laplace transform is x2 of s. You multiply those two, it becomes multiplication in s domain. Once you multiply, then you can take inverse Laplace transform, thereby you can do time convolution also. Okay, this is a simple question, very important, right? Convolution in time domain becomes multiplication in s domain. Using this property, we are going to convolve these two signals, right? E power minus 2t u of t into x2 of t is u of t. So just instead of convolving this using integration, what I can do? Taking the Laplace transform, e power minus 2t u of t, the Laplace transform is 1 by s plus 2. Laplace transform of u of t is 1 by s. Okay, you can multiply these two. So this is your convolution in frequency domain. One by s plus 2 into 1 by s. Okay, so 1 by s into s plus 2 is equal to a by s plus b by s plus 2. A by s plus b by s plus 2. Okay, now solve for a and b. Okay, using partial, I am writing this using partial fraction, right? That will be very clear in partial fraction. The roots are not, if the roots are real and not repeating, a by s plus 2 roots are there, s is equal to 0, s is equal to minus 2, so a is a constant, b is a constant. Now we have to solve for a and b. So I get this. So if you put s is equal to 0 in this term is gone. So you become 1 equal to 2a, so a equal to 1 by 2. Similarly, if you put s is equal to minus 2, minus 2 plus 2 is 0, so 0 into a is gone, so minus 2b, so b is equal to 1 equal to minus 2b, so b equal to minus 1 by 2. Now you substitute a and b here, so a is 1 by 2, b is minus 1 by 2. So what is the meaning? This is the convolution operation in what domain? What domain? This is in the S domain. How we got this? Just by multiplying the two signals. Laplace transform of two signals, that is your x1 of s and x2 of s. Now if you want things in Laplace domain, time domain, take inverse Laplace 1 by 2, what is 1 by s Laplace transform of u of t minus 1 by 2, 1 by s plus 2 is e power minus 2t u of t. Okay, so this is the convolution in time domain, right? So remember, see, what I am doing here is, it's fairly simple. I want to do convolution, right? Before, if you want to do convolution, what we do in time domain, we have to do integral x1 of tau into x2 of t minus tau d tau. Tau limit will be there. Okay, so this is the convolution formula we used, right? But what we do in using Laplace transform, what I do is, I am taking Laplace, instead of doing convolution, I am taking Laplace for each signal, then multiplying, then I am solving the using partial fraction. I am solving the expression. I am getting the signal in S domain. Back, if I take inverse Laplace transform, I will go into the time domain. So this method is very much easier than taking convolution integral. Instead of doing this integral operation, we are working only in time domain. Okay, working only in time domain is very difficult. By using Laplace, what we did, we temporarily we worked in what domain? S domain or frequency domain or Laplace domain. Finally, by taking inverse Laplace transform, we moved back to the time domain. This is one of the important application of Laplace transform. Then the another property is initial value theorem, IVT, initial value theorem. What is initial value? So initial value is in time domain, small x. Initial value is at time t equal to 0, can be obtained by taking limit s tends to infinite, s into x of s. S into x of s. Okay, so question is, if an x of s is given, find the initial value. Find the initial value. So what does initial value theorem says? That x of 0 is equal to limit s tends to infinite, s into x of s. So s into x of s. X of s is capital X of s given the question. I have substituted. Okay. Now in the denominator, I have taken 2 outside, so I'm taking s outside, s numerator s and denominator s gets cancelled out, so it becomes 2 into s plus 2 by s plus 2. Okay, here it should be, I have failed to write this, limit s tends to 0, limit s tends to infinite, limit s tends to infinite, limit s tends to infinite. Okay. So limit s tends to infinite. So if you substitute infinite by infinite, it is in indeterminate form. So if it is like this, what I can do is, I can divide numerator denominator by s. So 2 by s by s, s is cancel. Another 2 by s this side, right? So s by s is cancel. So 1 plus 2 by s. Divide numerator and denominator by s. I got this. Okay. Now you substitute infinite. So 2 plus 2 by infinite plus 1 plus 2 by infinite. Anything by infinite is 0. So initial value x of 0 is equal to 2. So this is the initial value of a given signal in Laplace domain x of s. Now I am going to verify this using inverse Laplace transform. I will get the signal in x of t. X of t I will get, in place of t I am going to put 0. Okay, and this answer will be the same. That is, using initial value theorem, I have got this answer. I have got x of 0. Now using time domain, in time domain I am going to put t is 0. Then I should also get 2. We will verify this. Okay. So remember this question. I am going to solve it again. But I am going to take the inverse Laplace, thereby going to work in the time domain. Okay. Now, so this is the question x of s. So in the denominator I am taking 2 outside. So 2 into s plus 2. So 2 roots are there. Okay, they are real. So a by s plus b by s plus 2. So I have to solve for a and b. That's what I have done here. You can look at here how I solve for a and b. Okay. So it becomes 2 by s into s plus 2, s into s plus 2 get cancelled out, right? So if I put s is equal to 0, this term becomes 0, this becomes 0, so 2 equal to 2a, so a equal to 1. Similarly, if I put s is equal to minus 2, this term becomes 0. So minus 4 plus 2 is minus 4 just a moment. If you put minus 2, it becomes minus 1. Minus 1 means just a moment. There's some issues there. S plus 2 a equal to 2. Then for solving b, I am putting s is equal to minus 2. Okay, fine. Yes, s is equal to minus 2. If I put, what happens? 2 into minus 2 is minus 4. Minus 4 plus 2 is minus 2, and here minus 2 is there, right? So here minus 2 minus 2b. So minus 2 will get cancelled. So b equal to 1. B is equal to 1. Okay. So substitute that a and b here. A and b here, right? So 1 by s is inverse Laplace transform is u of t. 1 by s plus 2 is e power minus 2t u of t. Now I need initial value. So t equal to 0. So x of 0 equal to u of 0 is 1. E power 0 is 1. U of 0 is 1. So 1 plus 1 is 2. You are getting 2. Okay. So what I have done here, using initial value theorem, very easily s into x of s, in place of s I can substitute infinite. I am getting 2. But here what I have done, I have taken inverse Laplace transform in time domain. In time domain, I have put t equal to 0. Thus, I have proved the initial value theorem. Initial value theorem helps to find the initial value in what domain? Time domain. Okay, initial value in time domain. Using this theorem, I can limit s tends to infinite, s into x of s. I can find out the initial value in time domain. Okay, next we have another theorem called final value theorem. FVT. Final value theorem. Very important thing of final value theorem is, in time domain, if I need the value at infinite, x of infinite is equal to limit s tends to 0, s into x, capital X of s. Okay, x of infinite is equal to limit s tends to 0, s into x of s. Okay, there x of 0 means limit s tends to infinite. Here x of infinite is equal to s tends to 0. But very important thing, we cannot blindly apply this, right? Only thing when we can apply is final value theorem is applicable only for the stable system. That is, pole should be the negative half of should have negative real part. That is in the left half of the s plane. Poles are nothing but the denominator roots. Okay, right. Now we take the same example. X of s is given. We are going to find the final value. Find this final value theorem. X of infinite is equal to limit s tends to 0, s into x of s. So this is the x of s. In place of, so denominator taking s outside. So numerator s and denominator s and denominator s gets cancelled out. Those two will get cancelled out. So now I am putting in place of s0. So 2 into 0 is 0, s0 plus 2. So it becomes 2s plus 2 plus s plus 2. In place of s I put 0 means 0 plus 2 divided by 0 plus 2. We are getting 1. Okay, so this is the final value. This is the final value. That is in time domain x of infinite. Okay, now remember, as I said earlier, that we can apply final value theorem only for the stable system. Okay, for that what you have to do is you have to check the poles. Poles are obtained by the equating the denominator of x of s to 0. So this is the denominator, s square plus 2s is equal to 0, taking s outside, s into s plus 2 equal to 0. So what are the real part of the pole is not negative, it is positive. Positive or 0. But it should be also not repeating. Note that point also. Pole should not repeat in the imaginary axis. Okay, if there is 2 zeros, then it is unstable. If it is 1 0 at the origin, it is stable. Okay. So we have seen this. What I have said here, final value theorem is applicable only for stable system. That is, pole should have negative real part or 0. negative real part or 0. It can, okay, real number is also a 0, no, right? Negative real part or 0 real part or 0, but it should not repeat. That should not be two zeros. That is another condition, right? Okay. So what you can do? We have to check this condition. Then only you have to use this expression to find out the final value. If it is violating this condition, if you are getting s is equal to 2, then I cannot apply final value theorem. Okay. Now we will verify in the time domain. For this, already we have found out the time domain in the previous slide. That is your x of t is equal to u of t plus e power minus 2t u of t. This is the inverse Laplace transform of the given question, right? So I will use the same expression here. This is in time domain. In place of t I am putting infinite, so u of infinite e power minus 2 infinite u of infinite. Okay, so if I put infinite, u of infinite is 1, so e power minus 2 infinite is 0. I am getting the answer as 1 plus 0. E power minus infinite is 0. I am getting the answer as 1. So I have verified the final value theorem. Okay. Sorry, I have minimized. Now it's clear, no? Right. U of infinite is 1. E power minus 2 infinite is 0. E power minus 2 infinity is 0. So u of infinity is 1. So 0 into 1 is 0. So 1 plus 0 is 1. So that's how I have solved using Laplace final value theorem. Using final value theorem expression, I have solved this. Using time domain, in place of t, I got 1. Both the results are the same. But important thing is final value theorem is applicable only for stable system. Okay. For checking a stable, for example, okay, I will show you another one thing, right? Let me say x of s is okay. What is the final value? Find small x of infinite. This is the question. Okay. So immediately you cannot apply the final value theorem, right? I cannot apply final value theorem like this. Final value theorem, x of infinite is equal to limit s tends to 0, s into x of s. If I apply this, limit s tends to 0, s into s square plus, sorry, s square minus 2s. Minus 2s. Okay. So what happens if we put 0? Here it is limit s tends to 0, s square minus 2s. If I put 0, what happens? 0 by 0 minus 0, it becomes indeterminate form. Multiply numerator and denominator by s square. So we will get s tends to 0, s square by s square is 1, s square by s square is 1, minus 2s by s square is s cancel, we will get s. Now you substitute 0 means we will get the answer as 1 by 1 minus 2 by 0. Anything by 0 is infinite. 1 by 1 minus infinite. Anything by infinite is 0. Okay, but this answer is wrong. Why? Final value theorem is applicable only for the stable system. For the stable system, we have to check the poles. What are the poles? S square minus 2s is equal to 0. That is, s is s into s minus 2 is equal to 0. So s is equal to 0, s is equal to plus 2. This is in the right side of the s plane. Right side of s plane. Or having a positive real part. Real part is positive. So it is an unstable signal. Unstable system. Okay, right? If x of s is a system, is an unstable system, is a signal, we say it's an unstable signal, unbounded signal. Unbounded, unstable system, I can say, or else you can say unbounded signal. Unbounded signal. So we cannot apply final value theorem. If the question is find the final value theorem of this, the answer is there is no final value. There is no final value, or it cannot be determined because it is unstable system or unbounded signal. If you apply this formula straight away, that's wrong. This is a wrong answer. Okay, right? Thanks for listening. Thanks for listening. Wish you a happy learning. Any doubts, please ask in the comment section. Wish you a happy learning again. Jai Hind.